Okay. How do you actually do non-rectangular regions? So I would hope I could at least find the volume of a cylinder of radius 1 and height 1 using integration. It's just pi, right? Because it's pi r squared h. This is 1, so it's just pi. It can't get simpler than that, right? But our rectangular Fubini's theorem doesn't quite cut it. So now we're going to talk about Fubini's theorem on type 1 and type 2 regions. And because I can't think of a less imaginative name than type 1 and type 2, I will just call these graphical regions. And you'll see why I say that in just a moment. The regions might look something like this. So a type 1, according to your book, region would look something like that. And the key feature is there is a graph on top and a graph on bottom. And these sideways things, they're constant, so it's flat. Flat here, and it's flat here. And this is x min, and this is x max. So flat sides plus graphical sides equals, if this is x and this is y, then it's type 1. And if this is y and this is x, then this is type 2. Okay? So all this is just saying is that you can put graphs on the upper or lower parts of the boundary. So let me just say what you can do within this situation. If you start off with your double integral, you can write it again as an iterated integral. And the key, you have to put the varying part inside. So the varying part is y in this example. So I will put the y here and I'll put the x here. So that means y min of x goes in the bottom, y max of x goes on top, x min goes in the bottom, x max goes on top, and everything else is the same. So inside, if y is on the inside, that means dy has to be here, and that leaves you dx out here. Okay, so this says first do y. First do this integral, and you're going to freeze x. So this is basically saying in our example, so again, if we want to find the volume of the cylinder, this is basically reducing a two-dimensional problem to two 1D problems. Right? So, I mean, in general, you can say that the curse of dimensionality holds in basically everything. Math, there's like in everything. So in computer science, and that just has the high dimensions. 2D is much harder than 1D. Right? So we cannot, evaluate 2D integrals, we can reduce them to 1D integrals. And this is just, again, another application of that. So we like 1D integrals. So let's do our cylinder example. So our region is this circle of radius 1, and the upper and the lower are 1 minus x squared. The reason I got that is that the circle satisfies that equation. That's the boundary. And if you solve for y, you're going to have plus or minus because of the squared here. Okay, so that's the upper region, that's the lower region. And our f is 1 because we're trying to look for volume. Right, so if we have a cylinder, the top part is flat. This is just 1. So our double integral, if you use Fubini, it just gives you, well, these are your y's. In fact, you could have done x's because it's a circle, but let's just do y's. So our y's go first. Right, because our y is the one that's varying. And x is constant. Right, so 1 and negative 1. So that means it's second. So let me just put down what the limits are. And then the inside is 1. And remember, y goes first. So we have dy. That's the first integral. And then on the outside, we need dx. Okay, so now we set out the integral. And this is actually, about as one-dimensional as you get. Because now, what's the integral of 1? It's just y, right? So this should just give you 2, because you subtract that negative sign. And this one is doable, right? Because you can just use a u sub. I would use sine theta. And that gives you dx equals cosine theta d theta. And if you remember the graph of sine, it achieves 1 and negative 1 at pi over 2 and negative pi over 2. And you can see that it's pi over 2 from the unit circle of radius 1. Right, because you go over pi over 2 angles. Okay, so that means if we're going from x to theta, our integral should go from minus pi over 2, that's the new theta value, pi over 2, that's the new theta value, and then we get 2 cosine theta, and then we get cosine theta d theta, let me just write it down again. So we have 2 cosine squared theta d theta, and this rest part is pretty routine because now we can just use double angle. And it's a good thing we have a 1/2 here. And this thing, it'll cancel out. Right, because if you graph cosine 2 theta, it's pretty easy to see that there's going to be negative signs. So those will cancel out. I mean, you could do the integral, and this will be periodic, right? So this will drop out. So you end up with just the constant term. So this is the integral from negative pi over 2 to pi over 2 of 2 times 1/2 plus 0. So we end up getting pi. So that's the volume of the cylinder. So in general, how do you distinguish between type 1 versus type 2? Which one do you do? Well, how do you look for them? Well, it's which one wiggles more. Which wiggles more, X or Y? So for example, is this a type 1 or a type 2 region? Well, Y wiggles more. So it's a type 1. On the other hand, you could do this one. So now X wiggles more. So I'm going to do a type 2 region for this one. This will be your X max of Y. This will be your X min of Y. And so in this case, you will put the Y min on the outside, and then you'll do the X integral on the inside. Remember, X has to match with X, and Y has to match with Y. Okay, that's all for this video.